Hey guys, so the second lesson we'll be talking about the cosine law or the law of cosines, the cosine law. Again, this is review from what you did in 8th grade, sorry, 9th and 10th grade. These are the three ways of writing the cosine law. A quick way to remember them is the A is what the cosine of the angle is. So if you have A on this side, then it will be cosine of A, right? If you have B on this side, then it's going to be cosine of B at the end. The order of this is the same, and if you have C on this side, then it's going to be the cosine of C. So A squared is B squared plus C squared minus 2BC cosine A. So you can change up, but if this is B, then that means these two have to be A and C, then that has to be A and C as well. If this is A, the beginning one is A, the end has to be angle A, that means the others have to be B and C, and the product is also B and C. For those of you that are curious, how does this cosine law come about? Let's see, let's explore. So if you have a triangle like this, my triangles have been terrible lately, but if I have a triangle, that's my triangle. That's about it. Okay, that's my triangle. If I have that triangle, let's say this is angle A, that means that side A, this is angle B, that's side B, this is C, and that is side C. Now I've drawn it equilateral, but really it's not an equilateral triangle, it's just any normal oblique triangle. Okay, I'm going to do this again. I'm going to draw a more representative triangle. Just bear with me for a second. Okay, triangle, bad triangle. Nope. Nope. Okay, that's a better one. Alright, so that's A and A, that's B. Doesn't matter where I put these things, and that is C. So if I draw a perpendicular here, then this side, which was supposed to be C, and let's say this is on a coordinate plane, so I have a y-axis, and then obviously this is going to protrude into x-axis. Then on this coordinate plane, this whole side was side C. The base of the triangle is side C. But since I know that this is some distance, this here is some distance x, right? This is some distance x. I don't know what I have here, right? I don't know what this is. This, you can think of this as C minus x, or if let me label it the other way around. If this distance from here to there is x, then this is going to be C minus some distance x. That's the height of the triangle, the spanning height of the triangle. So I'm pulling out a small triangle here. I'm pulling out a small triangle that is like this. Pulling out a small triangle like that, in which this is C minus x, in which this is the height of the triangle, and this is a. This little triangle is what I'm going to use to figure out my cosine law. Before I go ahead, I need to find expressions for h and for x in terms of the values of the bigger triangle that I know. So if I use angle A, you can see that the sine of A is equal to h divided by b, right? H divided by b. So I can end up saying h is equal to b sine of A. So instead of having h here, I can just have b sine of A. And if I also find the cosine, if I find the cosine of b, the cosine of A, sorry. The cosine of A will be x out of b, right? So yeah, the cosine of F will be x out of b. So that means x alone is b cosine A. I'm going to do this quickly and substitute for, no, sorry, back to this triangle, back to that triangle. I hope you can see that a squared is equal to h squared plus c minus x squared if I apply Pythagoras theorem to it. So h squared is equal to h squared. I know h, remember h is b sine a, so that's b sine a but squared plus c minus x. C minus x, let me first square it. That will be c squared minus 2cx plus x squared, and now I'm going to substitute for x as b cosine a. So this will be b squared sine squared a plus c squared minus 2c times x, but x is b cosine a, right? Plus x squared, but x squared is b cosine a squared. So b squared cosine squared a. Now I hope you see what I have. I have b sine a and b cosine a. B is common to both of them, so I can pull out the b squared. Then I'll end up with sine squared a plus cosine squared a. And then I have plus c squared minus 2bc cosine a. So you guys just remember from unit 7 that this is 1, right? This is 1. So I just have b squared plus b squared times 1 is b squared plus c squared minus 2bc cosine a. I have proved the cosine law for a, right? And I hope you can see that depending on what you name your sides or angles, you can get all of the other forms of the cosine law. That one that I've just done is this first version of the cosine law. Let's go ahead and apply it. Cosine law works when you have two sides and an included angle, right? Two sides and an included angle. And it also works when you have three sides. So it works for SAS triangles and SSS triangles. SSS you purely cannot use anything else but the cosine law, but SAS you can still use the sine law. It's just so easy to use the cosine law because the side that you don't have is the value that is on the left hand side of the equation. These values, if it's SAS, it's the side that you don't have. So from this, if I want to apply the cosine law, I know it's going to be, if I'm trying to find x, then the formula will be x squared is equal to the other two sides, their sum, minus 2 times their product times the cosine of the angle opposite to x. I'm basically saying what the cosine law is, right? So I know this is going to be, so if I try to write out, no, I'm not going to do that. X squared will equal to 6.5 squared plus 5 squared minus 2 times the two sides, 6.5 times 5 times cosine of 72. So again, I want to remind you, we want you to find the exact final answer, right? The exact final answer. In order for you to be able to do that, you won't substitute for these values as you go. You will plug everything in the calculator at your final step, and that's how you'll get your final answer. So my final answer is going to be the square root of 6.5 squared plus 5 squared minus 2 times 6.5 times 5 times cosine of 72. That's going to be my final answer, and I need to write all of this the way it is in a calculator. The cool thing about calculators is that you can just write all of this the way it is. So if I use the parentheses correctly, so if I do square root, open parentheses, 6.5 squared plus 5 squared minus 2 times 6.5 times 5 times cosine of 72, and then close parentheses at the end, don't forget to do that. Then it just gives me the answer straight away as 6.86, which I will write as 6.9 units or whatever. This question did not ask me to solve the triangle, it just asked me to find side x, so that's what I did. But if it said solve, then you'd have to go ahead and find all of the other unknown angles. Okay, use the law of cosines to solve for the missing angle of the oblique triangle. Write the answers at nearest tenth. So if you're given information like this, it's advisable to sketch your triangle. If this is angle A, then side A is 42. If this is angle B, then side B is 19. And if this is angle C, then side C is 30. They want me to find angle A. So this is the angle that I'm finding. Now, if you look at the cosine law, the way it's stated, a squared is equal to b squared plus c squared minus 2bc cosine of a, you can rearrange this so that you just solve for the value of a. So if I rearrange this, and I encourage you to do this on your own, if I rearrange this, I'm going to take away b squared. I'm also going to take away c squared. I'm going to take them both to the other side, or actually, if I rearrange this to solve for cosine of a, since this is negative, since this whole term is negative, it's what I'm going to move. So I don't have to deal with the negatives. This is just an alternative way of solving for it. So I'm going to add 2bc cosine a to both sides. 2bc cosine a. And then I'm going to take away a squared on both sides, right? I'm going to take away a squared. So I'm just doing all of this in one step. I'm going to take away a squared. I'm going to take away a squared on the side. So if I do that, then on the left hand side I'll be left with 2bc cosine a is equal to, on the right hand side I'll be left with b squared plus c squared minus a squared. If I want to solve for cosine a alone, I will divide both sides by 2bc. So divide both sides by 2bc by 2bc. 2bc cancels off that side. I end up with cosine of a, and I'm going fast through this because you have seen it before, but it's also not really very fast. So this is how I can solve for the angle using the cosine law. Do you have to know this formula in order for you to be able to solve the angle? No. If you substituted your values at this stage, you'd get the same answer as me who's doing this. The only difference is I am going to get the answer faster than you, because as soon as I see that I have three sides and I need to get an angle, I'll quickly remember that if I'm finding the angle, right, if this is angle A, then it's going to be A that I am subtracting, right? And if it is A that I am subtracting, then it's the other two sides that I'm adding, right? And if it is these two sides that I'm adding, they're also the ones in the denominator multiplied by 2. Multiplied by each other and multiplied by 2. Let me show you how this works. If the angle I wanted to find was B, right, then that means it is B I'm subtracting in the numerator. Since I'm subtracting B, I have to be adding A and C, and since these are the two that I'm adding, they are the ones that are in the denominator. And if it is cosine C that I was trying to find, then I am subtracting C. That means I'm adding B and A. The order doesn't matter, and that means on the bottom I'm multiplying B and A. So that's what I'm going to use to figure out the value of angle A. Angle A. So just substitute for B is 19 squared, C is 30 squared, A is 42 squared, divided by 2 times B, 19 times 30. All of that is equal to cosine A. But remember, if I want to get just the angle A, I need to get rid of this so I get space. If I want to find just the angle A, then I'll have to take the inverse cosine of that expression. So A alone will be the inverse cosine of 19 squared plus 30 squared minus 42 squared divided by 2 times 19 times 30. All of this can go in your calculator at once, and that's how you will get the most accurate answer. When I put that in, I'm going to go and say shift inverse cosine, open parenthesis, right, 19 squared, or We just do it this way. First do the numerator alone, denominator alone, then do the inverse cosine of the answer. Okay, 19 squared plus 30 squared minus 42 squared, 42 squared, close brackets, divided by 2 times 19 times 30, close parentheses. The inverse cosine of that is 116.2 degrees. So yeah, 116.2. Solve this triangle. Remember, solving means find all unknown sides and find all unknown angles. So if this is angle B and it's 88 degrees, then this is side A, it is 4.4, and this is side C, it is 5.2. That's side C. So first thing you want to do is find side B. Side B, using the format for B squared is equal to, then that means that will be A and that will be C. This is going to be A and C, cosine of B. So you use this one to find the side B. After finding the side B, you can use this one. Cos A is equal to, remember you're subtracting A, you're adding B and C, and then dividing to BC. You can use this to find angle A, and after finding angle A, you can use cosine C. That will be B squared plus A squared minus C squared divided by 2AB to find angle C. I find this faster to use, right? And I don't even need to show that I'm plugging in the numbers. I can just go straight from here and then write my answer. But if you think that sine law is easier for you to use after finding this, then go ahead and do that. But just look out in case the question is specifying that you should only use the cosine law. Okay, you guys go ahead and finish this. Another formula is called Heron's formula. Heron's formula is a cool formula that uses what is called the semi-perimeter, right? The semi-perimeter, just basically meaning half of the perimeter. The perimeter of a triangle which has three sides, A, B, and C, would be obviously A plus B plus C, right? A plus B plus C. But this guy Heron of Alexandria, or Heron, I don't know how you read that name, of Alexandria, found a relationship between the semi-perimeter of the triangle and the other sides of the triangle, and this is his relationship. Now this is a pretty cool thing to derive, or see how it gets to this. So if you're ever interested in deriving this, I can show you. I'm not going to do it here because it takes a bit of time, but if you're interested, then you can come and go through it just for fun. So the formula is, and again, S is the half perimeter or the semi-perimeter. This perimeter divided by 2. And this is something that can be calculated simply. Heron figured out a way to find the area of a triangle without knowing any of the angles in that triangle. As long as I know the perimeter of that triangle, the semi-perimeter of that triangle, and I know all the three sides. So if I have a triangle like this, in which this is 5 and this is 8 and this is, just for assumption's sake, is 4, right? Could probably not exist. But if I just know these sides without knowing any angle, Heron gave us a way to figure out the area. This is important for farmers who know the dimensions of their properties but don't know the area of their property. Like they know this side is this long and this side is that long, but they don't know the area, and they probably can't measure the angle. So yeah, this formula helps you to figure out the area without knowing any of the angles. It's called Heron's formula, and you can just let's try to use it on this example. First thing we need to find is the semi-perimeter. Remember, semi-perimeter is A plus B plus C over 2, which will be 7 plus 10 plus 15 divided by 2. That is 17 plus 15 is, Come on, people, you know this. 32 divided by 2 is 16, so S is 16. Alright, now the formula, area is equal to S into S minus A. It's not very hard to remember. S minus B and S minus C, square root, right? This S minus A, S minus B, S minus C. So it will be 16 into 16 minus 7. Sorry, I started with C. 16 minus 10, go in order. 16 minus 15 and 16 minus 7. So obviously you can see that the semi-perimeter is always bigger than any of the three sides. So if I simplify this, that's 16 times 6 times 1 times, this is 8. So 16 times 6 times 8 square root. I get 27.7, but you guys can check my answers. Square units. This one you need to specify that it's square units or units squared because you're talking about area. Alright, so this is your homework. Enjoy.